Good evening, everyone. Welcome to the 120th video on misconceptions in physics. My name is Ratankar Rao. I teach physics in an international school in Bangalore. And my hobby is to do these videos on YouTube. And towards this, we are working on misconceptions, which many of the students will have while they start solving numericals in problems, numericals in physics. And these misconceptions may be due to several reasons. So one of the reasons which was earlier highlighted was based on the comparison problems. And now currently we are working on the next type of problems, which is logical reasoning errors, errors that arises because of logical reasoning. Okay. So now, if you want to view my entire set of videos, either you can subscribe to my channel or maybe you can visit my website. The address of the website is URL is here, which is ratankar.com. So as you see here, this is my URL. You can visit this website and you'll be able to access all the videos. Okay, without wasting our time, let me begin with the actual tutorial, the problem. And every day, evening 7 p.m. sharp, one video will be broadcasted. You can view it if you subscribe it to it. Okay, so now, just a moment, let me pull this over here. Yeah, now. Two particles of mass m each are tied at the ends of a light string of length 2a. So I have two masses. M and m. They are being tied with the help of a string. Maybe I'll do one thing. Just give me a moment. I don't want to write here because we will not get space to write. Just a moment. Let me reshare it. Just a moment. I hope my screen is shared. Okay. So now let me write it over here. Two particles of mass m. Each are tied at the ends of a light string of length 2a. The whole system is kept on a frictionless horizontal surface, okay, with the string held tightly so that each mass is at a distance a from the center P. So this is the center P, and the distance here is a, distance here is a, okay. And then now the midpoint of the string is pulled. Now what are you going to do? You are going to pull it like this, right? Not vertically, okay. So you're going to pull it like this. And how are you going to pull it? With a small but a constant force. You're going to pull it vertically like this with a force F. Now, as a result, the particles move towards each other on the surface. Now, when you move it, what happens is, see, first of all, remember, we are not pulling it vertically. Okay, this is one of the biggest mistakes many students do it. Okay, so first you have to understand the problem. It says very clearly it is being kept on a frictionless horizontal surface. So, of the answers that I get, I observe that many of them will write, since this mass is m, this mass is m. The first kind of misconception is they don't read the problem correctly and they assume that it is a vertical pull. And if it is a vertical pull, then immediately what they think is that this force should be equal to ma plus ma, because you are moving up with an acceleration a. See, it says that with a constant force, so they assume that, okay, it's moving with an uniform acceleration. And thus they write this as 2mg over here. You're putting it upwards over here. So it is 2mg. That's what they write it over here, which is incorrect. This is the first misconception they get. Next misconception. Now, if at all, if I have assumed the horizontal pull, then what they do is they see that, okay, now when you are pulling it like this, what can happen? After 1 second, let us say, for example, this mass could be here, this mass could be here. The distance between them has been reduced. Let me consider this as x. Okay. So thus the midpoint would have moved over here, moved over here. So it would have been here like this, right? So therefore the distance between them is 2x and it's not 2a. That's what could happen. Now this is what is happening. Now the second misconception many of them do it is, anyway, see, this is moving upwards. It should move because there's no other force acting on it. It should move with an uniform acceleration because constant force. And finally, they write this as F equal to 2 times ma. Okay. And then they say, and what is the question here? Now the midpoint of the string is pulled upwards with a small but constant force. As a result, the particle moves towards each other. It's moving towards each other. The magnitude of the acceleration when the separation becomes 2x. When the separation becomes 2x. See, very easy. The problem gives you everything. That's what we say in advanced JE. If the problem gives you every information, okay, it's very easy to solve. Okay, but so every detail will be given, but you have to read it correctly. When you read it, things becomes more easier. Now, understand it, more important. Okay, so this is what they do, and finally they give the answer as A equal to F by 2M, which is incorrect. Okay, this is also incorrect, this is also incorrect. So here they have assumed horizontally, okay, but unfortunately, they have not read the problem correctly, and they have thought that A is equal to F by 2M. Now, when can I use this formula? Okay, before going on to the actual solution, okay, why is this incorrect? Why did they get this error? The reason is because they had thought, if I have two masses like this, if I have two masses, M and M here, and I'm pulling them with a string, with a force F, and you ask me what is the acceleration of this object, definitely for the whole system, the acceleration is equal to F by 2M. Nothing wrong. Okay, horizontally, frictionless, everything is correct. Okay, or maybe if two objects have been stacked like this, and then you pull it like this with the force F, even then your acceleration A is equal to F by 2. Each of mass M and M here, no friction. Okay, this is also correct. Or maybe you have a single mass 2M, even then it is correct. Now, what's happening in these cases is that the total mass is moving at the same acceleration. Now, unfortunately, in this case, what's happening is you are now pulling at the midpoint over here. When you are pulling at the midpoint, the force being a vector, now what can happen is this pull is not acted upon on this mass or on this mass. It is acted upon with the midpoint between these two masses. This is what you need to look at. So as a result of this, if you pull it like this, now see, you are pulling the midpoint. Now, why should the two particles come nearby? Simplest answer is, sir, they are connected a string. So if you pull the string, automatically masses will also come up. But physics point of view, you need to look at that. So physics point of view, we say that it's a pulling force, which you call as tension. Pulling force called as tension over here. Okay, and now this tension is what is making the difference. What we do is, let me consider that this tension, what will I do? Let me consider some angle. Let me consider this angle is theta. This angle is theta. When I consider this as my theta, then this should be your 90 minus theta, because this is right angle, right? Theta, this is 90 minus theta. So therefore, if I resolve this tension along two parts, now what do I get here? I get T cos theta on this direction. And along this direction, the vertical direction, I get T cos theta, T cos theta. And then here also, I get T cos theta, T cos theta. And along this direction, what do we get here? Along this direction, I get T cos of 90 minus theta, which is T sin theta, T sin theta. Okay. So therefore, now because of this T sin theta component, which is being pulled on both the sides, these two particles are now moving like this, right? So towards it, now we can now say that F is equal to 2T cos theta. And since they are now moving with an acceleration A like this, and as a result of it, I can now write MA is equal to T sin theta. MA is equal to T sin theta. So we are not going to take two accelerations because we are going to consider this is a whole system. So this is MA equal to T sin theta. Now what I will do is, let me divide one by the other. Because T is not known to me, I'll divide one by the other. So what do I get here? I will get this as T sin theta divided by 2T cos theta is equal to MA divided by F. Okay. Now this T and this T goes away. I have sin theta by cos theta is tan theta. Tan theta divided by 2. Tan theta divided by 2. Okay, which should now be equal to MA divided by F. Now what do we have here? I want tan theta. What is tan theta here? Now I said this is X, this is A, right? So now as a result of it, this length is A over here. What will this be? This length would be root of A square minus X square. Pythagoras theorem. Okay. The A square plus Y square equal to X square. Sorry, X square plus Y square equal to A square. So this Y square should be equal to, let me write it down if you want. Now this is my length of the string A. This is the mass over here. This is X. Let me call this as Y. I want to find out this value. Now, why do I need to find out the value? That is most important thing. Okay. Now, this is my theta here. Now, according to this, what is tan theta? Tan theta is opposite by adjacent, which is x by y. Tan theta is equal to x by y. Okay. So, but why I want in terms of a and x? So how do I know? How do I write? Y square is equal to a square minus x square. I use Pythagoras theorem, or y should be equal to square root of a square minus x square. So, which means, now what do I need here? I need the acceleration. So acceleration now, let me write it down here, which implies a is equal to f tan theta divided by 2m, which should now be equal to f by 2m into what is tan theta? Tan theta is x by y. X, I will write it like this, divided by y. What is y? Square root of a square minus x square. See, this is the final answer. So the answer looks to be very complex, okay, but this is the accurate answer. So this was a question asked in JEE advanced paper in 2007. So none of the problems are difficult. Every problem is easier only. But only thing is, we should understand what is the logic behind it. We should not just blindly say, yes, this is a problem given to me, I can easily solve. Okay, of course, if you have read the problem correctly, you will solve it correctly. If you have not read it and you assume, when that assumption comes into play, then things go wrong. Okay, see, how do I know that what is the method, whichever method I'm doing it correctly or wrong? What did I do first? I compared it with the already known problems. If I put two masses like this, if I put two masses like this, if I now change two masses like this, for example, if I, instead of putting two masses, if I put two masses like this, if I put two masses like this and pull it, okay, I can also ask this question, even acceleration will be same. Or maybe if I pull it like this, see, one problem, I'm giving you 4 or 5 different methods. Sorry, not 4 or 5 different examples, counter examples. And then ask the question whether the same method is applicable or not. This should be your thought process. Okay, your thought process should not be something like, given a question, let me answer. That is not your thought process. I mean, when you are practicing. So you should ask the question, why it is like this? Why should the question be solved in this manner? Why can't it be solved in the other way too? Do I get the similar answer? Do I get the same answer? If you are able to think on these lines, then JEE mains should not be, mains or advanced should not be very difficult. Okay, you can easily solve it. Okay, enough of lecture. Thank you, friends, for watching this video. If you like this video, do share, comment, and subscribe to my channel for more updates. Thank you.